All right, good morning.
Morning.
How's everyone doing?
Doing pretty well. How are you doing?
I'm doing pretty well, thanks. All right, so I want to mainly go through the previous ODP, the current ODP, and then I want to spend some time talking about VI and just kind of thinking about how we can be more efficient in using VI. Just some stuff to try and think about. So, but let me talk about some other stuff first. So, let's talk about VirtualBox issues. So, if you're not running a system that boots into Linux, I've suggested using VirtualBox. And I think I mentioned this in an announcement. I also posted a video. VirtualBox does not always work as well under Windows as it does under Linux. But if you have Linux, you don't need to run VirtualBox to run Linux. I've been playing around with it. So there's some features you can change and turn off in Windows to make VirtualBox work better. For me, doing so broke the ability to use WSL, the Windows subsystem for Linux, but it makes VirtualBox work like a champ. So take a look at that video. If you're having trouble getting VirtualBox to run, you have to basically turn off something called Hyper-V and a virtualization option. They're listed as features under Windows, but they break VirtualBox. Once you have VirtualBox up and running, it's nice to be able to share folders and clipboards, and those do not work automatically out of the box. Okay, so I posted a video on how to do that. Basically, you have to install some extra add-ons. They're called guest editions. Run a script from the guest edition CD, which is a virtual CD you load into your virtual optical drive. Reboot your virtual machine, and now you can have a shared folder in your Linux environment that's the same folder as it's in your native system, be that Windows or Linux. So you put a file into your folder in your virtual system, it's available outside and vice versa. And it also makes the clipboard work, so you can copy and paste between your virtual environment and your physical system. So that's a nice way to be able to move information in and out of your system. Yeah, not having the clipboard is a real bummer. But it works great when I try this, and like I say, I'm trying this on top of a Windows 10 system, fully updated recently, so that seems to work. So that's a good way to go. All right, let's talk about some bash things to consider. So this is related to the previous ODP you already did, 407, which you already turned in. I just want to highlight something that I've said a few times now, but I had this conversation with a bunch of people yesterday in email. So here's a pretty benign looking bash script, okay, and it's illustrating the way that I've said you should do if statements. Okay, so this is from that bash how-to guide on Canvas. If space bracket bracket space, first thing space equals space, second thing space bracket bracket. Okay, and I've said that multiple times, and I don't just like saying the word space or bracket bracket. Okay, I'm saying it because if you write an if statement like this, it will work if you're comparing two strings. Okay, and so here's a sample if statement which if hello is equal to goodbye, it should print out the word bad. Well, it's not going to print out the word bad because hello and goodbye are not the same string. But here is an if statement that looks almost the same, but it does not write the if statement condition the way that I've just said that you should write it. In particular, I'm missing the spaces before and after the equal signs. And that makes a difference, right? Now, hello is definitely not the same thing as goodbye. This should not print out very bad, because that if statement should fail. But in fact, it does print out very bad. Right? Why? Because this is not actually comparing to see if this string is equal to that string. Why? Because there's no spaces before and after the equal. These spaces are important. Okay? Bash is super, super, super picky about this. Now, if you want to become a Bash expert, if you want to dig into what exactly this is doing and why this condition is true, right? That's great. There's a lot to learn there. You can do a lot of digging. You become really good at this, okay? But if your goal is to be able to write Bash, get your ODPs done, get your assignments done, write Bash on the exams and get an A, don't go down this path, okay? That how-to guide I posted on Canvas shows you one way to write an if statement, one way to compare strings, one way to compare numbers. And if you learn that way, it will work. If you don't learn that way and you just try to write things like this, you know, sometimes it may work, sometimes it may not. If I was comparing two strings that were the same, this would look like it works great, right? But if I happen to have two strings that are not the same, well, it doesn't work anymore because this is not comparing those two strings. So parentheses, double parentheses, brackets, funny keywords, all that other stuff. Unless you want to get into that and dig into the details of it, just stay away from it. Just stick to the way that we've been doing it in class, stick to the way that's described in that how-to guide. Okay? Nothing wrong with doing, you know, parentheses, things like that. But for this course, I would say keep it simple, which means learn one way to do these things and stick with that. Okay? It will keep you out of trouble, especially at 2 a.m. when you're trying to find that last bug in your code and you start writing new code and you end up accidentally writing things like this, and that can drive you nuts, right? So suggestion, unless you're already a Bash whiz, right, get in the habit of doing things that one way that we've said, you know, is guaranteed to work. So why does LT work all the time but not less than? Was there any reason it was programmed that way? I will never try to understand why anybody who wrote anything related to Linux did what they did. I don't know what mindset was going on there. I know there's a ton of history around it. I know a lot of the stuff goes back into the 70s. But my gut feeling would be that, you know, less than has a very specific meaning in Bash and in Linux in general. It's used for redirection of, say, input. So I can run a command and say less than file name, and it will read from that file instead of reading from standard in, instead of reading from my keyboard, for example. And I think maybe that's one reason why we have -LT-GT. But there are contexts where that less than sign will work. Okay. I decided to emphasize the -LT-GT because it's harder to do those and get them wrong, right? So, but again, lots of different ways to do all of these things. That's a mixed blessing, right? All right, so let's talk about the next ODP. For this ODP, you're writing a C function, so we're switching gears now in this course. We'll come back to Bash later, but for now we're switching over to playing more with C. So we're going to have our first ODP in C. We're going to talk about VI today. We're going to talk more about C the rest of the week, and this week's ODPs will all be C functions that you're going to write, or C programs. So let's take a look at this. Okay, this is going to be really specific. Okay, I suggest you do not tune out and say, yeah, I know C, I'll figure this out later. Okay, you should be able to figure it out from the README, but it's going to be easier if you play along right now and actually watch us do this. This first ODP, the actual C code is trivial. And I'm going to write it for you, and I'm going to show you exactly what your function should look like. Okay? The purpose of this ODP is not to see if you know how to write C code. The purpose is to get to know the way that we're going to assess C functions. Okay, so we're going to talk about test beds, we're going to talk about the assess command, we're going to talk about linking in your function to a test bed, and so on. So let's take a look at the README first. And anybody who's just hopping in, you just missed like super critical information. So go back and watch it later on. All right, so ODP 410A. Okay, this is open right now, closes tomorrow morning. So you're writing a function named inc, I-N-C, for increment. Okay, anytime we use a function in C, we have to prototype it. Prototyping means telling the compiler about this function before we actually write the function. So a prototype statement looks like this. Type of thing that the function should be returned. This is either a variable type or the keyword void. The name of the function, parentheses, and then a list of the types of arguments going into this function. Int, comma, char star, or whatever. Close parentheses, and then a semicolon. The semicolon is important. It says this is not the definition of the inc function, this is the prototype. I'm not going to tell you the code for inc right here, I'm just telling you what inc looks like. Okay? So when I give you an ODP where I'm asking you to write a function, I'll always show you what the prototype should be. Okay, function named inc, it's going to take one integer, it's going to return an integer. Alright, what does the function do? It accepts an integer, it returns that integer plus 1. So it increments its argument. Alright, so let's make a directory. Let's write our increment function. So I'm going to put this in a file called inc.c. Okay, put your function in a file named inc.c. And I'm going to write my increment function. So I'm calling my argument n, but I didn't have to do that. I could name it anything that I want. Okay. So it's going to return an integer. The function name is inc, and it takes one argument, which I'm calling n. And that's my whole increment function. Okay. Take an argument, add 1, return that. If I call this bubble, then I would return bubble plus 1. Okay, the name of the argument is sort of immaterial. But the name of the function has got to be inc. Alright, so there's my increment function. Let's keep reading the README. Okay, it says you need to supply your own main function for testing this routine. How do I know if my inc function works? I can't run it. Right, I don't have permission. If I give it permission to execute and I try to run it, I'm going to get in all kinds of trouble. Because it's not a bash script, it's a C function. Okay? So I have to compile it. And I have to somehow tie it to a main program. Alright, so the buzzword here is a test bed. A test bed is typically an apparatus, a piece of equipment that you put something into to test it. Okay, so it might, apply inputs, it might vibrate the thing, it might expose it to temperature, it might, do different things to it. It's something you put your thing into to have it tested. Okay, for us, our test bed is going to be a piece of software. It's going to be a main program which calls our function and tests it out. It's going to call our function with a number, it's going to take the return value and see if that's, the thing we passed plus 1. Alright, you need to write your own test bed. Now I'm going to give you a test bed for running through the assessment system, but you can't use that to test your function. You have to write your own main function. This is really important. guarantee I'll have people emailing me later saying, hey, I wrote my function, I linked it in with the test bed, I run it, it doesn't do anything. Okay? Got to write your own test bed. So let's do that. So I'm just going to make something called C. So this is my own test bed for testing my increment function. That's not how we write comments in C. There's how we write comments in C. Okay, so I'm going to include standard IO.h. I'm going to make my main function. And I'm going to do the following. I'm going to have an integer y. I'm going to say y equals increment 10. And I'm just going to put a print statement, which basically says, you know, I called increment 10 and it returned, and I'm going to print out the value of y, which was the return value from increment 10. Alright, and then I'm going to compile this. GCC, put my output into an executable program called main. Compile my function inc.c, compile my main program main.c. Alright. These two can go in either order, but -o main, that has to be side by side. -o says, this is what I want to call my output file instead of a.out. I want to call it main. Okay. If I put main.c here, it's going to overwrite my main.c. My code is gone. So gcc-o, what you want the executable to be called, and then your input.c files. Okay, if I do this, sometimes it will give me an error. Because generally, we want to prototype our functions. Okay, this was a simple enough use case that it accepted it, and I have some switches turned on to be forgiving. But in general, prototype your function. Alright, so this is just in there so the compiler knows when it sees inc, it should expect an integer, it should return an integer. Because inc is not defined in this file. Right? Inc is never given to the compiler until I do that GCC line. But inside this file, it doesn't know what inc is. Alright, so this is my test program. It should take in a 10, it should set y equal to 11, and I should be able to see that that works. So let's GCC that again. Let's go ahead and run main. Hey, inc of 10 returned 11. That's pretty good. I'm feeling hopeful now. Let's see, since we are compiling both the files with GCC, that's why we can call the function even though it's in a different file. Basically, we could actually compile these in separate GCC lines and then link them together. But GCC, at the very end, it puts everything together. And yeah, even though inc is defined in something different from main.c, we can still get to it. Just like printf is not defined in main.c, but we can call printf. Okay, so yeah, there's this linking that happens that resolves these references to functions that aren't defined in this file. Alright, well, I want to do a little more testing. So I'm going to test, 25, and I'm going to test -25, and I'm going to test -1. And I'm just going to do more exercising of this function because inc, it's a pretty complex function, right? So I want to make sure that inc works in more than just this one test case where I passed it a 10. So I'm going to pass it other things. Now, this is one way to write a test bed. Just hardwire a bunch of calls to your function and see what it returns. I could put this in a loop. I could run I from, -10 to 10 and call inc of I and print out the result. I could take an argument from the user while the program's running, pass that to inc, print out the result. It's totally up to you how you test your function. Okay? But the important thing is to write a test bed and use it to make sure that your code works. So So I'm going to run this test bed. So inc of 10 returned 11, good. 25 returned 26, minus 25, negative 24, and negative 1 returned 0. We seem to be in good shape. Alright, so I'm feeling pretty hopeful that my my inc function is doing the right thing. So let's look at the README again. Okay, test your program thoroughly. Well, we've done that. We're convinced that it works. Time to assess it. This is not how to assess your program. If I try to do that, I'm going to get all kinds of errors. Okay? You don't assess your test bed. You have to assess the test bed that I've provided to you. Okay? Main is my program. It's effectively a totally arbitrary program. So to run your function through the assessment system, you have to link it with this program. This is the test bed that I've written and supplied to you. Okay? So make sure inc.c is just your function. Don't put a main program in inc.c or you'll mess up the assessment there. Okay? So inc.c contains your function. Compile it into an accessible test bed using this command. gcc-o, I'm going to call my executable program inc. I'm going to compile inc.c, that's my function, and I'm going to link it in with /temp/odp410a main.o. That's the test bed. Okay. Once I compile those together, I'll have an inc that I can actually run through the assessment system. So let's do that compilation. Now I've got my executable program inc, right? So this is my function that I wrote. This was the test bed that I wrote. This was the executable test bed for my tests. This is the executable test bed to run through the assess command. So I can assess inc.c. Double check you're about to assess your code for ODP410A, the increment function. Good. Let's run the G command. I got 10 out of 10. Lucky me. I'm good to go. Exit out. We're done. Okay. I cannot use the inc function to tell if the inc program, I can't use this to tell if my function works. If I run inc, it doesn't do anything. Okay? This is not intended for you to execute. This is intended for the assessment system. So you got to write your own test program, link that with your function, run it, test it, make sure that your code works, and then link your function with the test bed. That's this. Get an executable file, assess that. Is that clear? And this can feel kind of awkward or kludgy or something, but we're going to do this pretty much every time that we get an ODP that involves writing a C function. Okay, I'll give you a test bed, I'll give you instructions for linking to it. You'll write your function, test it yourself, then link it with the test bed and assess it. So this is like a hello world, okay? And again, you know, our function itself just looks like this. Take an integer, increment it, return it. All right, let's go on. Let's talk about VI. So VI is an editor. You learn it in CSE224B. You use it in there. Most students hate VI. Okay. Makes no sense to them. It's kludgy, it's slow, it's confusing, and it tends to mess up your file. So I can't tell you how many students I've heard really, really hate VI. Okay, and if I used VI the way I see most students use it, I would hate it too. Okay, because for the most part, when I see people using VI, they're not using it really the way that I think VI is supposed to be used. It's like trying to use a hammer when you should be using a screwdriver, right? Or maybe it's like trying to use a hammer by holding the metal part in your hand and hitting the nail with the wooden handle, right? It's a terrible way to drive a nail into a board, right? Well, it's not that hammers are terrible tools, it's that you have to use it a certain way to really make it work. Now, you can still drive a nail into a board by banging it with the wooden handle of a hammer, but it's really slow and you hit your thumb a lot and your hammer breaks pretty frequently, right? So let's take a look at VI and sort of think about how I think it's meant to be used and how you might use it to be more efficient. So let me give you my standard disclaimer here, okay? Editors are like religion, they're like politics. Everybody has their favorite editor. Everybody has their feelings about editors. Some of these feelings are very strong. I'm not going to tell you one editor is better or worse than another. Okay? What I'm going to do is offer you some of my experience with using VI and things that I've done that have let me be more efficient in using VI. And I'd like to offer the perspective that when one is writing code, you're best served if you can spend your time and energy and focus writing code. If you're debugging, you should be able to concentrate on debugging. If you're trying to figure out an algorithm, you should be able to concentrate on trying to figure out an algorithm. And too many editors pull you out of that. Too many editors demand your attention, right? If I go into Notepad or Notepad++ and I need to find a function, right? I've got to do Control F and or go to Edit Find and type in the name of the function and then find the next button and click on that. And if you know keyboard shortcuts, that's a little more efficient. If I need to make a change on line 97, I have to scroll until my 97 on the side appears and then go down and click on that line. I would like, when I'm working on code, to be spending as much of my time and energy and focus on that code, and as little as possible doing other things. Okay, so let me talk about how we can use VI and not have to spend a lot of energy thinking about it. Somebody posted a suggestion in chat for vimadventures.com. I haven't looked at that yet, but I think I might have seen it before. Sounds like it's worth a look. All right, so let's make a test file. Let's see. I deleted it. All right, so let's just make a test file. All right, so here's my bash RC, just to play around with. So first thing to know about VI, there's two modes. There's other modes, but there's two main modes when you're sitting in VI. There's command mode and there's insert mode. Okay, insert mode is the mode where whatever you type goes into your file. So for example, if I hit an I, right, everything that I type goes into my file. And the reality is most students will spend their entire VI session in insert mode. Right? They open VI, they say insert, they spend their they do their editing and then they hit escape :WQ or escape :X. Okay? Insert mode is probably not where you want to be most of the time. Most of the time you should be in command mode. This is the mode you're in once you hit an escape. Now, if you're in insert mode, you can move around using your arrow keys. And you can type things. Right? But this is not the most efficient way to operate in VI. So for example, if I want to get rid of this line, I go to the end of the line with my arrow key. I hit the backspace key, and now my line is gone. And if I want to type a new line, right, I could say right. I'm going to suggest the only time you should be in insert mode is if you're inserting characters. If you're at a point where you want to add something to your file, go into insert mode. If you're not at a point where you want to add something to your file, get back into command mode. Okay, hit an escape key. The reason being that when you're in command mode, you can do all kinds of things in VI. You can move around, you can copy and paste, you can delete, you can search, you can run command line arguments, you can execute shell commands, you can pull in the contents of other files, all kinds of things, but only if you're in command mode. If you're in insert mode, you're just typing, and whatever you type goes into your file. All right. All right, let's talk quickly about getting out of VI, and then we'll talk about command mode. So when you're in VI, there's a few things you can do. Usually we type a colon. This is only from command mode. We type a colon, and then we can do any of the following. We can write a W to write the contents of our file out to disk. We can do a Q to quit. We can do a WQ to do both, write the contents and then quit. We can also do a W exclamation mark if we're trying to write a protected file. It'll tell us we can't write it. If we have permission to override that protection, we can force it to write by :W exclamation mark. :Q exclamation mark will quit even if we've got unsaved changes. So it's mostly WQ and exclamation mark. So if I try to quit, it'll say, you haven't saved your changes. If I want to quit anyway, :Q exclamation mark. If I've got changes and I want to save them, I can say :W. If I've got changes and I want to save them and I want to quit at the same time, I can do :WQ. Okay, some people do :X to get out instead of WQ. That's fine. Some people do 2 Shift Z's to get out instead of WQ. That's fine too. Here's going to be my first real suggestion to you, though. Don't use :WQ unless you want to write changes to your file. If you haven't changed anything, don't use :W. Right? And in particular, if I try to quit and it says, you've got changes, don't just do :WQ. The only time you want to do :W at all is if you've got changes you've made that you want to save. So a lot of people use VI to look at their code, right? And a lot of people spend their time in insert mode. While you're going around and you're looking at your code and maybe you accidentally typed something. If I :WQ, any changes that I made get saved in my file. So I would say get in the habit of :Q when you want to quit if you did not intend to make changes. And if it says you got unsaved changes, use :Q exclamation mark. Alright, I don't know if WQ exclamation mark would make sense. Maybe if you had permission issues it would work. But I can say I don't think I've ever typed :WQ exclamation mark. Usually the exclamation mark is when you want to force it to quit, even though you've got changes. But hey, you know, it should work. I think the exclamation mark would override permission complaints. So if I make my file read only by setting the permission bits and I try to write it, it'll say it's read only. So if I do that, it'll force it to write. All right, the other thing about VI, don't use Control-C. Control-C does not get you out. Don't use Control-Z. Okay, eventually people discover that Control-Z is a really, really good way to get out of commands that you want to get out of, but it does not end the command. And in particular, if I do a Control-Z, and then I try to exit, right, it'll complain. But I can force it to exit, and then I can go back in. And the next time I try to edit my file, what happens? I get this annoying message with the big red banner saying attention and all of these. I mean, it's half a page of text for me to read. So we get the dreaded swap file error. Alright, so what do you do when you get this message? What it's telling you is that you had an edit session in progress and something interrupted that. Now it could be that you walked away and you came back and your cat had stepped on your keyboard and disconnected you from the internet, or maybe the internet just went down, or you did a Control-Z and logged out, right? A lot of things can cause this, but it's saying basically you were in the middle of an editing session and things got interrupted. Okay, so my suggestion, when you get this the first time, take the abort option. Get the heck out of here, okay? Because this might be, 500 lines of bash code that you need to turn in tomorrow. Let's not do anything rash, okay? Let's just get out of here. So let's just say A for abort, okay? And then let's see where we are, and let's make a copy of our program. So I'm just going to make a file called test.saveme. Right? And if I try to edit testing, then you get this message again. So if you do an ls-a, you're going to notice there's this .test.swap file. So what happens is when you start to edit a file, it creates the swap file to let the world know that you're editing this file. And if somebody else tries to edit it at the same time, they'll get that same warning message. And if your editing session goes away, you'll get that warning message. Okay, so now go into your file. So I'm saving it outside of VI, outside of everything else. I've just got a test.saveme. That's my current version of the file. Now I'm going to go back in. Let's open it with the open read only option, the O. So I'll type in O, and you can look around at your file. Make sure that this is what you want. Okay. Looks pretty good, or maybe you had 50 changes you made that you hadn't saved, and those are missing from here. Okay, so if that's the case, quit out of here. Don't WQ, right? If you write it, then you're potentially losing your changes. So if you want to try to recover your file, right, :Q, get in the habit. Okay, let's go back to VI. There's an option for recover. Let's hit the R. Okay, so it says recovery completed, check everything is okay, blah, blah, blah. Hey, that line that I wrote is back. Right? Okay, this is the version of the file that I want. Okay, I'm going to write that out. I'm going to do a :W to save that. I'm going to quit. Well, if I edit my file again, I'm still going to get that annoying message. So let's quit out of that. Do your ls-a, remove this swap file, remove.test.swap. But only do that after you're sure that you've recovered any changes you wanted to recover. Now I remove that. Next time I VI my file, I'm back to where I should be. All right, good with that? All right, let's talk about moving around in VI. So we know that we can use our arrow keys to move, right? And if I wanted to change that $0 at the end of this line to be a $1, I can do this. And right now I've forgotten what I'm doing, right? I had 10 things in mind that I was going to do to my program. I've just forgotten them all because I'm basically, you know, sitting here negotiating with my computer, right? So I can backspace and change that to a 1 and so on and so forth. All right, so other ways to move around your file. First of all, the official ways to move HJKL. Okay, HJKL. If you play Rogue, right, and I recommend people play Rogue for practice. That's a game, it's on the server, ROGUE. Official way you move around there, HJKL. So H moves back, L moves to the right, J moves down, K moves up. Okay, similar to arrow keys. To make the arrow keys work, you need to set something up in your VI environment that's set up for you by default in a file that I put into your login directory when I created your account. But not all VI systems understand arrow keys. Every VI system will understand HJKL. Okay, but does not work in insert mode. If I'm in insert mode and I start typing J, I insert a bunch of J's. Okay, but if I'm in command mode, J moves down, K moves up. Okay, we can also move down into the beginning of the next line with just an enter. So enter is a quick way to move around. K lets us move up. We can also move to the end of a line with a $sign. So I wanted to change that 0, $sign and a couple of H's, I'm right there. We can move to the beginning of a line with a 0, right? Or you could hit an enter and move up, but 0 is easy, right? Takes you back to the beginning of a line. And you can also use a caret. So a 0 moves you to the beginning of the line, caret moves you to the first non-space character on a line. I don't use carets much, but I used to. Alright, so HJKL lets you move around. Moving around a character at a time gets old really quickly. So we can move a word at a time with a W. W moves from word to word, where a word is, you know, stuff separated by word separators. Mostly looks like words, but takes some getting used to. B moves backwards a word. Alright, so that's the faster way to move around. We can put numbers in front of most commands. If I want to move over 7 words, I can just say 7W. 7W, 7W. If I want to move over 10 spaces, I can say 10L. If I want to go down 15 lines, I can say 15J. Alright, so we can start moving around pretty efficiently like that. Again, you got to be in command mode. If you're in insert mode, all of these things will just become part of your file's contents. If you want to move a half screen forward or backwards, you can use Control D for down, Control U for up. So Control D scrolls me down quickly, Control U scrolls me up. So let me make my file bigger. So now I've got 300 lines. So I can Control D to move down. I can Control U to go up. If you want to move even quicker, Control F moves you forward a whole screen. And Control B moves you back a whole screen. I mostly use U and D for up and down. If you want to go to a specific line, you can type the line number followed by an uppercase G. All of this is in this video that I posted in the beginning of the quarter, by the way. So I compile my code and it says, you know, syntax error line 212. I can type 212G and that takes me right to line 212. And I can see here, you know, I'm on line 212. If I want to go to line 57, 57G, I'm at line 57. Now if you have line numbers on the left, you can scroll until you get to that line, okay? but number one, scrolling takes time, and you have to read your line numbers to get to 57, right? And now you're looking at line numbers and processing line numbers instead of code, and it takes up real estate on your display, and it's visual clutter. All right, so you can get to a line number with a Shift G. If you want to get to the first line of your file, it's just 1G because that's the first line. How do you get to the last line on your file? If you don't know how many lines you have, just hit a Shift G with no number. That takes you to the last line. All right, Control G also shows you where you are in your file. So I'm at line 100. Control G says I'm editing the file test. It's been modified, which means if I try to quit, it will warn me. It's got 313 lines. I'm 31% of the way through the file. All right, let's talk about inserting. So mostly we use the I command to start inserting text. Type in I, start typing in text. Okay, there's other ways to insert. For example, suppose you're at the end of a line and you want to add something after this. Well, most people will go down to the next line, put some stuff in the beginning, go back to the beginning of the line, do a backspace, right? If you use the letter A, that says insert after my current position. That's an append. So I inserts before, A inserts after. No, there's not a test on this, but I strongly suggest people try it, right? Just to see if this works for you. Nothing wrong with Notepad++. But we will see a lot of things we can do in VI. All right, so I inserts before, A inserts after. If you want to put a new line below your current line, you can type in O. So if I want to put a line down here, just type in O. That opens up a new line below, and you can type there. If you want to insert before your current line, type a Shift O. That opens up before. This is a recurring motif. The shift version comes before, the unshifted version comes after. We'll see that a lot. All right. If I want to change a word, let's say I wanted to use C++, right? Instead of GCC, I can say CW. That deletes a word and lets me type something in its place. By the way, a period always repeats your last command. So if I want to change this to G++, I can just hit a period and it repeats that command. All right, last one I'll tell you for now. A Shift R basically puts me into overwrite mode. So a Shift R lets me type, but it doesn't move my text over. It lets me just overwrite the characters that I'm currently seeing. This is nice when you're making ASCII art. So when you're making a comment block, for example, if you have a block of asterisks and you want to fill in the spaces with text, use a Shift R. It lets you overwrite those spaces, but your asterisks will stay where they are. It lets you make pretty comments that way. All right, so still want to talk about deleting, copy and paste, joining lines, searching, and then a whole slew of command line options, which is really where you unlock the power of VI, because we can search for regular expressions, we can do replacements with regular expressions, and this is where VI really kind of opens things up. So we'll talk more about that tomorrow, and then we'll switch to talking about C programming, doing input, parsing input, and dealing with command line arguments. All right, so work on the ODP. Let me know if you have questions with that, and I will see you next time. Thank you.